Alright, so this is going to be our notes on predicting chemical reactions, and we've been talking about the types of reactions. We talked about a single replacement or displacement. We talked about a combustion reaction. We talked about double displacement or replacement reactions, and a couple more. The ones we're really going to be worried about today are, you're going to see here in a minute, are going to be the single displacement. We're going to be worried about the combustion reaction, and then we're going to be worried about the double displacement reactions. So let's go ahead and put this thing up here. Okay, what's that? Okay, so we can kind of see here. Let me just type this in. So the ones we're worried about are single displacement, double displacement, and combustion. And the one thing that's really going to help us, especially with these first type, this single displacement, is going to be this activity series. And let me show you what this looks like. I'll open this up here. And this activity series is just a chart. It shows you how metals react with each other, because a lot of times that's what you're going to have in an equation. I'll show you in just a minute. So you have, here's all the metals. Let me bring this down. Here's the activity series. I'm not going to show you all of them, but lithium, potassium, calcium, sodium, and so on. So these are the most active at the top. These are the least active at the bottom. If you went all the way down to the bottom, gold is the least reactive. So that's why you're going to find gold by itself for the most part. It doesn't really like to grab onto other ions. But also in this activity series are halogens, so chlorine, fluorine, bromine, and iodine. So you may have a cation attached to one of these. A lot of times it'll be a Mg2, an MgCl2, an MgF2, fluorine, chlorine, all those. And if you have that and you have another metal by itself, how will they react? And you just follow this chart. Chlorine is the most reactive, iodine is the least reactive. Okay, so that's kind of the activity series, and that's going to help us with single displacement reactions. And then we also have to worry about the idea of solubility. Solubility is talking about the ability of a substance to be absorbed in water or in another solvent, I guess. A lot of the reactions we have are going to be aqueous or dissolved in water. So that's going to be our main question, are the chemicals or are the compounds that we're going to see how they react, are they soluble? Because when we do double replacement reactions, we need for the reactants to be soluble, and then we need the products to be, one of them needs to be soluble, the other needs to be insoluble, and we'll talk about that in a minute. So those are probably our two main concerns, the activity series whenever we're looking at a single replacement, and then the solubility question whenever we're talking about a double displacement or replacement. You can call it either thing. Okay, so also though I haven't mentioned yet is this idea of combustion. Combustion reaction is where you take an organic compound, usually carbon, and you see it reacts with oxygen to produce the same products. So we look here, whenever you want to ask yourself, is the reaction a combustion reaction? You're looking for two things. A carbon compound, here we have C4, and then is it mixed with oxygen as well, which is like a catalyst that gets the combustion reaction going. So if it is, that tells us we have a reaction going, and it's going to be a combustion reaction. So we'll just do that. And then we know on the other side it's going to have two things. It's going to have CO2, and then it's also going to have H2O. Okay. And then really we're done. And the only thing we have to remember is, like we have to remember with all types of chemical reactions or equations, is it has to be balanced. And sometimes these are a little bit harder to balance. So these are probably going to give you the most trouble whenever you're trying to balance. So if we did C4 here, we put a 4 in front of this one, that'd match that up. Then we have H10. We're going to have to put a 5 in front of that one. And then we have 5 oxygen. We have 13. So we'd need 6.5. Right, that would give us 13. And then we know we have to put a 2 all the way through it to make it balance out right. Oh, that would give us 13. That would give us 8. And that would give us 10. Then we come back, make sure it's balanced. 8 carbons, 20 hydrogens, and then we have 26 oxygens. We have 16 here, 10 more, 26. So that's a combustion reaction. We just ask ourselves about the reactants. Are the reactants, is one of the reactants carbon? Is the other one oxygen? Then we have a combustion reaction. And then the products will be carbon dioxide and water. And then there's also energy release, like you put wood in your wood stove, you cause this reaction to occur, and then you produce CO2 and water, but you also produce energy. So that's your combustion. Then we look at a single displacement reaction. Now we're going to kind of turn to the activity series we looked at. So we have iron and copper nitrate. And we want to know, is this going to be a reaction? And let's see. Not working too good for me. So, trying to give me the arrow, I'll just copy this arrow. So we want to know. And the main thing we're going to look at is the activity series. So we have to ask ourselves, this one that's by itself, is it stronger than the one that's joined with something else? If it is higher on the activity series, then we know that this reaction will occur. And then we can just rewrite it. Let's see if we can go find it. Right here. So we're going to ask iron. Where's iron? There's iron. And there's copper. So iron is higher, so then we know that it's going to react. So then we can rewrite it. I'm going to leave a little space here. I'm just going to copy this one real quick. And then we're going to have copper by itself. And then it's going to be a +2. You may not get this part of it yet, but we can see that copper should be a +2 because Cu and the 2 is coming from the copper. Nitrate is a +1. We're just looking at the ions they would form. This is an important part to consider whenever you're rewriting the equations on this side, or the compounds on this side. So we know copper +2, and this one kind of can confuse us because we're not sure what is the charge, because iron can be multiple charges. So really, if we were doing this one, sometimes it won't do this, but really it should be charged. So we're going to say it's a +2, right? So then that's going to give us NO3, and then we know it's iron 2, so we make it a 2 after that. And by using the activity series, we can see that this reaction would occur. Now, if we had chosen one iron, something that was above iron, like if we went back to this activity series, and we had iron reacting with aluminum, we would see aluminum is higher, so in the end there would be no reaction, is what the result would be. This one there is, and this would be the final. We check and make sure it's balanced. 1 iron, 1 copper, 2 nitrates, 2 nitrates. Okay. Now we have another one, FeCl2 plus Mg, and it's kind of a little different one. And copy this. We now have to ask ourselves not the iron or the metal part, but now we're looking at the halogen part. Okay, and actually we want to look at and see if we had, for this one, the Mg and Cl2, and I'm going to change this actually a little bit. So let's say we had Br2. Okay. So let's say this was the reaction. It's FeCl2 and Br2. So we have the two halogens, chlorine and bromine. And the only thing we're looking in this reaction, is bromine stronger than chlorine? If it is, if it's more reactive, that means it will replace the chlorine. We're not worried this time about the metals. So then if we go look at our activity series, chlorine is more reactive than bromine. So this. Chlorine more reactive, no reaction. Okay. If I wanted to show you one that could happen, let's see. How would if we did Fe I 2 plus Cl 2. Okay, and we want to know, does this reaction occur? And we go look at our activity series again. We'd see chlorine is higher than iodine, so the reaction would occur. And go back to it. Yep. And we would put, so the chlorine would replace the iodine. And we'd have FeCl2. We'll fix that in a minute. Let's find the iron, I guess. And then we would have by itself, the same thing. We'd have this monoatomic molecule. And these are halogens, so we'd have I2 by itself. They're always going to form this diatomic where it's two of them. Those halogens are. Then we just check it, I2, we got one iron, we got one iron, we got two chlorines. So this is now a possible reaction. And that's your single displacement with a halogen. Okay. Now the hardest ones are the double displacement. And you really have to ask yourself two questions. You have to ask yourself, are the reactants soluble? And when the products that you produce, you need one to be insoluble and one to be soluble. So let's add an equation. Okay, so we have this chemical reaction, or possible chemical reaction, and I just put this side in the products, and what you're going to do eventually is just predict them. But I'm just putting them in. I think it makes it a little easier at first for you to see what I'm talking about. But if you remember the two questions we're asking, the reactants soluble. So if you see these two reactants, and we look at them, the first question we always ask is, are they soluble? And I'm going to give you a chart here, and I'm going to show you what this one looks like here in a second. But we want to look at these. Barium chloride and sodium sulfate. Are they soluble? So we use a chart we have. Let's go there. So here are compounds. It tells you these compounds, if they have lithium, sodium, potassium, or ammonium, they're always soluble in water. Then these ones are always insoluble. NO3, C2, H3O2, this is acetic acid. These are always soluble as well. So just the compounds, these are your cations. These ones are always soluble. And you have this polyatomic ion in here. And then you have these negative ions, NO3, and then the acetic acid, they're always soluble. Then you have these special cases, okay, chlorine, bromine, and iodine. And you just look here, they're insoluble with this, they're soluble with any other ion. And then we have, sulfate, soluble with these, except these. And then carbonate and phosphate, they're soluble with these cations, but insoluble with any others. And then hydroxide and sulfur, they give you these rules. So then if we go back, you just need to have this handy until you learn it. And then so we look at barium chloride. So chlorine soluble with, I don't see barium, it says soluble with any, so they are soluble. So we could put on this one AQ. So that fits our first requirement. So the first reactant is soluble, and that's our first question. These both have to be soluble. So then we go to sodium sulfate. So we go to that list again. We look for sulfate. Your sulfate soluble with, except strontium, barium, silver, mercury, and lead. That's not the case. This is sodium. And we can even look at sodium, always soluble, so we know that that is soluble as well. So we just put AQ after that. So then our last question, then, we have to ask ourselves, so far we're good. We know our reactants are soluble, and then we have to look on this side. Are any of these insoluble? We need one of them to be insoluble, the other one to be soluble or mix in water. So we'll start with barium sulfate. We go back to this, looking for sulfate soluble with all ions except barium. So it's insoluble. And what that's going to tell us as well, So that matches one part of it, right? So we need a insoluble, and this is going to be a solid. It's going to form something called a precipitate. We've kind of talked about that already. So that matches one of them. So one's insoluble, so we need this one to be soluble. We're going to go look one last time. And looking for sodium, always soluble. Chlorine, insoluble with just those, soluble with, so it fits both. So that works. So it's going to be AQ. And that works. So those are, that is a double replacement or displacement, whatever you want to call it. Okay, and that's how you do them. So this should be your introductory notes. You should be ready to try a couple examples or try a worksheet where if I just gave you this, so if I erase this, I would say, is this a possible double displacement or replacement reaction? You would first ask yourself, are these two soluble in water, aqueous? We find out they were. And if they were, we would then switch. The barium would then take the sulfate, and then the sodium would then take the chlorine. We want to make sure we have these formulas written out correctly as well. Keep an eye on the subscripts that tells you what the charge of everything is, right? And then you can rewrite them on the other side and then check and see if they're soluble or not. And products, one must be insoluble or form a solid. Sometimes they form a gas as well. And one must be soluble or aqueous. And then the single replacement, we're just using an activity series. Is iron stronger than copper or more reactive? If it is, the reaction can occur. If it's not, no reaction. And then we look at these halogens. Is the one that's loose or free by itself, a monatomic molecule like Br2, is it more reactive than chlorine? We find out with this one it's not, so there's no reaction. But here we changed it a little bit. We have iron 2 iodide, and it's trying to react with chlorine. Chlorine is more reactive than iodide, so then it will take this iron instead, and we'll end up with iron 2 chlorine plus iodine gas. And then we could put in our gas and all that kind of stuff as well. So, but that's that. And then the combustion, we're just looking for, is there a carbon compound with oxygen? If there is, we just write on the as products carbon dioxide and oxygen. And that's kind of the notes for this. Let me know if you have any questions, and go ahead and do your worksheet.